So let us try to understand how to find out the moment of inertia of the unsymmetrical eye section as shown in the figure. This is the top flange, this is wave, and this is known as the bottom flange. And these are the dimensions which are given for this particular eye section. Let us consider this first rectangle as section 1. This is our second section, and this is our third section. Now, first step is always to find out the centroid of each section and then the corresponding values of x1, x2, x3 and y1, y2, y3. So let us join the diagonal of this particular rectangle. So you can see that these diagonals they are joined. So this is the centroid of the figure 1, this is the centroid of the second figure, and this is the centroid of the third figure. Now, taking this axis as the reference, we can measure the distances or values of x1, then x2 and x3. So, distance of the centroid of the first section from this reference is x1. Distance of the centroid of the second section from this reference is x2. And distance of the third section from this particular reference is x3. So, as you can see that this x1, x2 and this x3 all are same and they will be equal to this larger width, that is 200 upon 2, that is 100 mm. Similarly, we can find out the values of y1, y2 and y3. So for the measurement of the y1, we have taken this axis, that is the extreme bottom of the section as a reference. So this is y1, that is nothing but 20 upon 2. So it is the distance of the centroid from the reference. So that is 10 mm. Then y2 will be equal to this 20 plus this particular half of this 100. So it is 20 plus 100 by 2. Then this particular distance of the centroid of the third figure from this reference will be equal to this 20 plus 100 plus half of this 20. That is this particular value. So in this way we can calculate the values of x1, x2, x3, then y1, y2 and y3, and then we can easily find out the value of the centroid. So these values already we have seen, that is x1, x2, x3 and y1, y2, y3. Then area, so area of this particular first rectangle will be equal to width into this depth, so it is 200 into 20. Then for the second rectangle it is 100 into this particular width is 20, and for the third figure it is 100 multiplied by this depth, that is 20. So x bar will be equal to a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. Just substitute all these values and you will get the required answer. Similarly for y1 also, it is a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3, and you will get the value of y1. So let us try to understand how to find out this ixx and iyy. So this is width of the first section, that is the bottom flange, it is b1, that is equal to 200 mm, d1 is given as 20 mm. Width of the second section is b2, its depth is d2. Width of the third section is b3, that is top flange, and its depth is 20 mm. So using this data we can easily find out ixx and iyy. Now to calculate the value of ixx, consider y bar and find out the radius of gyration. So it is y bar minus y1, y bar minus y2, and this is again a mod sign, that is we have to take into consideration the positive values over here. And then according to the parallel axis theorem, ixx1 is 1 by 12, this b1 d1 cube plus a1 k1 square. Similarly for the second section it is 1 by 12 b2 d2 cube plus a2 k2 square. And for the third section, again it is 1 by 12 b3 d3 cube plus a3 k3 square. And these are the corresponding values that we have already calculated by substituting these values of b1, d1, a1 and k1 and the respective values for second section and for the third section. So total ixx will be equal to summation of all these particular values. So it is equal to 21.659 into 10 raised to 6 mm raised to 4. Now for the calculation of iyy, similarly consider x bar. So k1 will be equal to mod of x bar minus x1. So in this way, we have calculated the radius of gyration for all the three sections. Similarly, Iyy is given by, for the first section, Iyy is given by 1 by 12 d1 b1 cube plus a1 k1 square. Similarly, for second section, similarly for the third section, and total value will be equal to summation of all these particular values. So Iyy for the given section is 15.066 into 10 raised to 6 mm raised to 4. So in this way, we can calculate the moment of inertia of the unsymmetrical section, that is I section in this particular case. Thank you for watching. Do subscribe to our channel. Thank you very much.